Okay, this is Mr. Borchert again. We're going to start off by looking at Euclid Elements, Book 1, Proposition 3, the tutorial for the homework. So what I'm going to do is I'm going to describe to you what we're going to do in this, and then we're going to go through questions 1 through 3. So what we're given in this homework is two different segments, CG and AB is bigger than CG. And what we're going to end up doing is cutting segment CG off of segment AB so that we have AE, this segment right here, which is the same size as CG. And that's what we aim to do. So let's go step by step and see how we're going to do that. First of all, question 1 asks us, what are we going to do in this proposition? I want to summarize what I just said, but I want you to do it in your own words. So if you need to, rewind and tell me what we're going to do. If you want to look up here, the enunciation is always the part that is going to tell you what we're going to do. For question 2, I want you to read the enunciation and the given over. Remember that this says AB is greater than CG. Now read question 2. Are the segments equal to one another? If not, which of the two segments is smaller? Look up in the given for the answer. For question 3, you need to draw the given in a box using a straight edge and a ruler. In order to do this, you're going to take a straight edge and a ruler and draw point A, point B, and connect them. Then you're going to draw another point labeled C and another point labeled G and connect them. That is everything you need to do for that box. Draw this diagram in the box. Questions 4 through 6 have to do with the construction. So what we're going to do is go through the construction step by step and then give you a hint on questions 4 through 6. Alright, so what we're going to do is start our construction over, and then we're going to create segment AD so that point A is congruent, at point A so that AD is congruent to GC. Then we're going to create a circle with center A and radius AD, and then point E is going to be the intersection of the circle. So let me show you what that will look like. In GeoGebra, again, I start off with A, B, and connect them. Then I'm going to make CG so that CG is smaller than AB. Now the next step was to make something called AD that was the same length as CG. So the proposition that lets us do this is proposition 2, which we just went over in class. AD is equal to CG. Now, since we've done that proposition before, we don't need to go through all of those steps to do it. We can just draw a line that is the same size as CG and assume that we're able to. The next step in the construction says create the circle DEF with center A and radius AD. So I'm going to use a compass to create a circle starting at A with radius AD, and I'm going to mark off the place where they intersect as point E. And since the circle is called DEF, point F has to be on here somewhere also. That is the entire construction that you need to draw in the box to the right. You'll need to use a compass and a straight edge to draw all of this, or you can try to freehand a circle. Question 5 asks us, why do we need to use proposition to create segment AD? The hint I'm going to give you for that is, what does proposition 2 tell us that we're able to do? Write your answer next to question 5. Question 6 is, what does postulate 3 do? You probably noticed that up here it references postulate 3 when we make a circle. Look in your notes and tell me what postulate 3 does. Now we're going to answer questions 7 through 10 on the back. Questions 7 through 10 use the diagram off to the right over here. Question 7 says label CG as being 3 inches long and AD as being 3 inches long. So up here, you're going to label CG as 3 inches long and AD as 3 inches long. That's all that question 7 asks us to do. Question 8 asks us why AD is also 3 inches long. In order to answer this, you'll need to go back up to the construction step 1 and find evidence why AD is 3 inches long if CG is 3 inches long. Question 9. How long is segment AE, this segment right here? And then they need to give a reason why. My hint for you is to remember that A is the center of the circle and D and E are both on the circumference of a circle, so that AD and AE are both radiuses of the circle. You can also go down to the proof and read step 4 to help you. Question 10 is, imagine that the segment AB, that's the entire thing from A to B, was originally 5 inches long before we cut off segment AE. How long is segment EB? So how long is the remainder? So remember, the entire thing was 5 inches long. We cut off segment AE, which you should know the length from question 9. And you have to answer how long is the smaller part, EB. The rest of the homework is to read these 4 lines as preparation for tomorrow. A is the center of circle CDF. A is the center of circle DEF. Therefore, the radius AE is congruent to radius AD. 5. But CG also equals AD because of what we did in step 1 of the construction. So AE, AD, and CG are all congruent to each other. That means that AE is congruent to CG. Therefore, the given segments AB is greater than CG, and what we did was we cut off AE from AB so that CG was equal to AE. QEF, quod erat faciendum, we have done it.